sine and cosine graphs, amplitude, and period. Let's look first at the basic or parent graphs of y equals sine x and y equals cosine x. And we'll start with the graph of y equals sine x. From the unit circle, I'm going to use the values for sine at 0, pi over 2, pi, 3 pi over 2, and 2 pi. So when sine is on the circle, when we're at 0, the sign is 0. So I put a dot at 0, 0. When we're at pi over 2, the sign is 1. So pi over 2, 1 is the next dot. When we are at pi, the sign value is 0. So that's the third dot. When we're at 3 pi over 2, the sign is negative 1. That's the fourth dot. And when we're back around to 2 pi, the sign is 0. The last dot. So when we connect these, it makes a wave. If you continue the wave on the left side, then you can see the graph of y equals sine x from negative 2 pi to positive 2 pi. And that is the parent graph for sine x. And of course that wave continues on in that pattern in both directions forever. At 0, the sign is 0. We can construct the graph of y equals cosine x in a similar manner. From the unit circle, we can get the following points for cosine. When we are at 0 on the unit circle, the cosine is 1, so that's this dot in the middle. When we're at pi over 2, the cosine is 0. When we're at pi, the cosine is negative 1. At 3 pi over 2, cosine is 0. And back around to 2 pi, the cosine is 1. So we can connect those. And you can see the wave on both sides. So at 0, 0, in the middle of the graph, but the cosine is 1. It's up at its highest point. These types of graphs model anything in the natural world that makes waves, like ocean waves, sound waves, springs, pendulums, etc. The height of each wave is called the amplitude. And for the parent graphs, the amplitude is 1. From the x-axis, the highest it ever goes is positive 1, and the lowest it ever goes is negative 1. Now, if we put a constant in front of the trig function, then we're going to change the amplitude, which causes a vertical stretch or shrink. So let's look at the graph of y equals 3 sine theta. And x can be where the theta is, really any variable, but it's usually a theta or an x. So the number in front, the number multiplied in front, is the amplitude. So for this graph, the amplitude is 3. That means the highest it will go is positive 3, the lowest it will go is negative 3. I'm going to follow the same pattern as the parent graph. It's a sine graph, so in the middle I'm at 0, 0. And then when I move to pi over 2, I'm at the highest point, which is now 3. At pi, I cross again. At 3 pi over 2, I'm at the lowest point, which for this graph is negative 3. And then back to 2 pi, I'm at 0 again. So there's the right side of the wave. And then the left side, I just mirror it. It's going to go to the lowest, cross, not really mirror, just continue, cross, highest, and cross. So there's the graph from negative 2 pi to positive 2 pi. It's hard to make these look nice. Just do the best you can. Y equals 1/2 cosine theta. So that my amplitude now is 1/2. It's going to go a half above the center and a half below the center. The cosine graph in the middle, when you're at 0, starts at its highest point. So the highest point for this graph is a half. And then at pi over 2, it crosses. At pi, it goes to its lowest point, which is negative 1/2. then it crosses at 3 pi over 2, and then it's back up to its highest point again. And then continue the wave on the left side, crosses, lowest, crosses, highest. If we have a negative out in front of our function, the entire graph will flip over vertically. So when I look at this graph, y equals negative 2 sine x, the amplitude is 2. The amplitude is not negative 2. The amplitude is 2, and then the negative causes our graph to flip over. So let's think about how the parent graph normally goes. For sine, it starts in the middle at 0, 0. And then at pi over 2, it normally goes to its highest point. But this graph is flipped over. So when I move to pi over 2, I go to the lowest point, negative 2. And then it crosses, and then it's going to go to the highest and crosses again. So all your high points and low points change places when there's a negative out in front. So that's what happens when you stretch the graph or shrink the graph vertically. You can pull it up, you can stretch it so it's higher and lower, or you can squash it down so that it doesn't go up as high or down as low. Now, if we want to stretch or shrink our graph horizontally, spring, and if you pull the spring apart, it's stretching out horizontally. Or if you push the spring in together tighter, it's shrinking horizontally. And to do that, you multiply within the function. So if I have this model, y equals a sine bx, the a stands for the number being multiplied out front, and that gives us the amplitude. But the b, a number multiplied beside the x or the theta, changes the graph horizontally. It will stretch it or it will shrink it. One complete wave of the graph is called the period. And so when you stretch or shrink horizontally, you're going to change that. You're going to change how long it takes for one complete wave. And to calculate that, you use the formula that the period equals 2 pi divided by b. And then that's going to give us the fourth number on our scale when we plot out our scale on the x-axis. To get the other numbers, you're going to take what you get for the period and you're going to multiply by 1/4, 1/2, and 3/4. That will give you the other three numbers on the scale. And all of this works whether it's sine or cosine. The formulas are the same. So let's practice. We've got y equals 2 sine of 2x. So 2 out in front is the a value. So that's our amplitude. Then the b value is also 2. So the period will be 2 pi divided by b. 2 pi divided by 2 is just pi. And so it only takes a distance of pi to complete one wave. And if you'll look at this graph that I've done on the graphing calculator, the black wave is just the normal sine graph. From 0 to 2 pi is one complete wave. But if you look at the red graph, you complete one complete wave by the time you get to pi. So it's like our spring has been pushed in closer together, and you can get more waves in the amount of time it takes to get from 0 to 2 pi. Now, this is difficult to draw. It's difficult to try to draw the stretched or shrunk graph so that it looks different than the parent graph. So we're not going to really worry about visually being able to tell it's squished in or stretched out. We're just going to change the scale numbers with the understanding that it has been horizontally changed. So we'll just follow the same pattern as the parent graph, but the scale will be different. So let's go back to this. Y equals 2 sine 2x, and we said that the amplitude was 2. And we said that the period is 2 pi divided by b, which is 2 pi divided by 2, which is just pi. Now that's going to be the fourth number on your scale, and you can see I've already written the scale in, and pi is at the end. Then to get the other three values for the scale, you multiply by a fourth, which would give us pi over 4, multiply by a half, which gives us pi over 2, and multiply by 3/4, which gives us 3 pi over 4. So the scale is pi over 4, pi over 2, 3 pi over 4, and pi. And then, of course, you put the negatives on the left side. Now, we still follow the same pattern as the parent graph. It's a sine graph, so in the middle, there's a dot at 0, 0. And when you go to the right, you go up to the highest point. Then next you cross, then you go to the lowest point, and then you cross again. It's the same pattern as the parent graph, it's just the numbers on the scales are different. And then on the left side, I'll go to the lowest, cross, highest, cross. So it's sort of like we've zoomed in and only looked from 0 to pi and see what the graph is doing. Let's try a cosine. Y equals negative cosine 1/2 x. Okay, there's a negative there. That's going to make the graph flip over. And I don't see a number in front of cosine. That means there's an invisible 1. So my amplitude is 1. Again, it's not -1, it's just 1. The negative means flip the graph. So 1 is the A, 1/2 is the B. So the period is 2 pi divided by 1/2. Sometimes this gives people problems with these fractions. Remember, when you divide a fraction, you flip and multiply. So that would be 2 pi times 2 over 1, which is 4 pi. So now, instead of completing a wave by the time you get to 2 pi, which is what the parent graph does, it takes all the way out to 4 pi to complete a wave. If you'll look at the graphing calculator display, the black graph is the parent graph, and by the time you get from 0 to 2 pi, there's a complete wave. But the graph of this function, negative cosine 1/2 x, is the red graph, and it doesn't complete a wave until it gets all the way to 4 pi. So it's like our spring has been stretched out. Again, that's very difficult to draw by hand and make it look like anything, so we're just going to change the scale. And so let's kind of rewrite. Our amplitude is 1. We know we're going to flip it because of the negative. Period is 2 pi divided by 1/2, which I already showed you. When you flip and multiply, comes out to be 4 pi. So that's the fourth number on the scale. Then to get the other three numbers, you multiply by a fourth, which would just be pi, by a half, which would be 2 pi, and by 3/4, which is 3 pi. So the scale is pi, 2 pi, 3 pi, 4 pi. Now we follow the parent graph pattern to graph. For cosine, when you're in the middle, when you're at 0, 0, you go up to the highest point. But this one's flipped over. So at 0, I need to go down to the lowest, which is -1. And then you cross, highest, cross, lowest. And then the other side would be cross, highest, cross, lowest. One more, this is y equals 3 sine 1/3 theta. So the 3 would be our A, 1/3 would be B. The amplitude is 3. The period is 2 pi divided by B, which is 1/3. Again, I have a fraction. So if you have a fraction, you have to flip it and multiply, and that's 6 pi. That's going to be the fourth number on the scale. 6 pi times a fourth. You're going to have to reduce diagonally a little bit. 6 and 4 both divide by 2, so that it would leave you with a 3 and a 2. 3 pi over 2. And then 6 pi times a half would be 3 pi. and 6 pi times 3/4 reduced diagonally is 9 pi over 2. You need to show all of this work. All of this needs to be written down beside your, or above or beside your graph. I need to see all of that. So I've put the scale on the graph, 3 pi over 2, 3 pi, 9 pi over 2, 6 pi. It's a sine graph, so that pattern is that when you're at 0, the first dot is at 0. So in the middle, it starts at 0, 0. When you go to the right, it goes to the highest point, which is 3 because that's the amplitude, crosses, lowest, and crosses. And then make sure you do the negative side as well. It's going to go down to the lowest, cross, highest, and cross.